Okay, without further ado, I'm going to move to the next section. This is where we are going to understand from Mr. Vinay G. Rajagopal, ISV Technology Lead Architect for Partner Ecosystem, all about how do we build edge applications. Please put your hands together to welcome Mr. Vinay G. Rajagopal. Thank you.
What are the key drivers, right, from a technology perspective, from a business perspective. Then what I've also done is put together a few technology stack that you could probably adopt as a part of your edge computing initiatives. Right? And that's what I believe is a strong key takeaway of the session. Now, having said that, let's get into what the definition is, right? I'll give you a couple of examples. I'll try to keep that simple so that we all can relate to it. Now, imagine you're driving a car. The car has this self-driving capability, right? And you're cruising all your way, and there's an obstacle right in front of you. Now, this obstacle, imagine all the sensors on the device, all the cameras, all that feed. You take that data, send it to cloud, process that data, take that decision of what is the next best action to be defined, and then you send that processing, whatever the data you've processed, whatever the decision that you made, back to the end device. And by the time all that data comes through, you pretty much go, you probably would have banged that obstacle in front of you, right? So again, like Raghav and Vikas mentioned, padna nahi chahiye, I would say togna nahi chahiye, right? So it becomes absolutely important for you to kind of process that data within that footprint, right, within that device. In this example, it's a car. Now, I'll give you another example. Let's say you're at an oil rig somewhere at the Gulf of Mexico, and you try to fix the mud pump there. Now, you have this cool headgear where you wear that mixed reality, augmented reality device, and you're following the digitized instruction manual to, usually these MRO processes are you disassemble the equipment, you replace whatever the component has to be replaced, and then you reassemble the entire equipment, right? And then you test for the functionality. Now, let's say all of this is rendering on this very cool headgear, and I turn around. And that image is flickering, right? So that what we define as DOF, the degree of freedom, it can be very impactful on your eyes and the strain that it brings together. So you have to ensure, however you move, the application or the rendering of that application, the rendering of the 3D digitized instruction manual, the rendering of where you're overlaying that onto what you're seeing as a part of the mixed reality. All of that has to be in sync. Now, that's ultra low latency that we're talking about. Now, what is edge? Edge is basically that platform that brings the required computing resources at the very place where both data producers and data consumers exist. And you have to process that data faster and make that decision faster. So that is pretty much what edge is. Now that we've understood what edge is, let's look at what are those key business drivers that kind of bring all of this together, right? Like I said, first and foremost is how do I really foster that data? How do I make those decisions really fast, right? That can be a huge business differentiator, right? Now, at the same time, those applications which are very, latency sensitive, they need to be processed at the edge. You can't afford to, move them to cloud, make those decisions and bring it back, right? Because there's an absolute need of sub-second, kind of processing capabilities there. Now, having said all of this, there's always the rule of the land. You need to be very careful. Raghav mentioned about personalization. You need to be very careful where you process that data, where you store that data, because end of the day, the privacy rules, the GDPR, the aftermath of GDPR, which is CCPA, all of that plays a very, very important role. So having said that, these seems to be the strong business drivers, but let's not neglect the fact what the benefits are, right? So if you look at it in a nutshell, what you're actually doing is you're limiting your data. What that means is, what is that you want to process and solve within that edge footprint. What that means to a business is the fact that the cost attached, there's a parity, by the way, right? The amount of data and the cost attached to move that data over a pipe and the bandwidth cost, right? At the same time, storing that data. Now, on top of it, add the need for, data encryption for the data in motion, data encryption for the data at rest. So there's cost attached to it. So that benefit gets passed on to businesses. Now, the other one, very important, is edge also brings some kind of a resiliency for your operations team, right? The fact that even if there is a connectivity loss to your core data center or to the cloud, you still are capable of isolating those issues and still achieve what you want to achieve at the edge itself. So that kind of translates into business benefits. Now, the other point that I want to bring to your attention and why all of this is important is you kind of optimally using the resources at the edge site, right? You're doing it for that specific use case, for that specific industry sector, and you're solving that problem, which means you're not really going across, one fit for all kind of a scenario, right? So that kind of translates into business drivers specifically, right? The value, the cost optimization, the resource optimization, overall efficiency that we would like to drive across any of our initiatives. Now that we've understood what is edge, what are the business drivers, what are the benefits? Now, the benefits also comes with its own complexities, like I was saying. What are those complexities? One, scale. Because we're talking about really managing, hundreds of devices. It's not easy. How do I really distribute my container application? How do I roll back if there's an issue? How do I manage the data replication across different, edge sites versus the core data center or the cloud that you might have? That's not easy. Secondly, interoperability. When you're talking about devices, there's a heterogeneous set of devices, be it software, hardware, whatever. How do I really manage them? How do I remain agnostic so that I have this ability as an organization to be adopted by a larger ecosystem and therefore sustainability? Otherwise, at some point of time in your product roadmap, you may not achieve a larger customer base. Now, okay, we've got scale, we've got interoperability. How do I keep that consistency, right? For an organization to be efficient, you need to make sure the experience is consistent across all of these footprints, be it your cloud or your data center or the edge footprint. Now, if there is consistency for your developer team, for your operations team, and also for your security teams, the velocity is going to be so high that you could, as an organization, come up with solving those niche industry problems rather than spending time to keep the lights on, right? So this becomes complexities that you'll have to take care at the beginning of the design itself. Now, is this all true? What are those enablers which are really pushing that envelope and making edge a reality? Now, we've all been quite fortunate to have come from the back forth of 5G auctions. So 5G, and if you look at 5G, is one of the, among the three pillars, one of the main pillars is URLLC, which is ultra reliable, low latency, very sensitive applications, right? So that is a reality now. The fact that with 5G, you could achieve network slicing on demand on a private network, which gives you that real capability of driving network performance across all of these various footprints. Now, at the same time, we've been very fortunate. Last week, I saw the CEO of MasterCard announced that India is going to be the #1 digital economy in the world because of UPI architecture, right? You've seen UPIs predominantly, taken over the digital transactions at least. And what that means to us is that these architectures cannot be built on the traditional, client-server-based architectures anymore. Right? They have to be containerized and so on and so forth. What we've also seen, and I've been told just before getting into this session, one of the marketing folks told me that the highest number of connected devices, we've talked about edge, we've talked about connected devices, all the instrumentation and intelligence that brings to organizations are cars. I've told connected vehicles are the number one right now in terms of the true IoT adoption. And what is happening from an architecture perspective, I'm sure most of you guys would be aware of that, is this V2X architecture, which is vehicle to anything. Today, vehicles are instrumented, which means they are interconnected, which means they're intelligent because they have data. And this data can pretty much relay. If you bring the smart city components to this, the vehicle can talk to a smart pole. The vehicle can talk to a pedestrian, right? And there are architectures that, I'm sure some of you guys might be exposed to. It's called wallet on wheels. So tomorrow, when you drive your car to a fuel station, you're not only, fueling, you're topping up your petrol, diesel, or whatever it is, you're also making the transaction. Your car is capable of completing the financial transaction, all the settlements, et cetera, et cetera. I don't want to get into what payments are, but it is capable of, right? So V2X, UPI, wallet on wheels, all of this, and of course, Industry 4.0, the robotics now, and smart cities, for example, are all driving this into a reality. So if I'm sure pretty much most of organizations that you guys represent would already be, as a part of your initiative. If not, it is the right time. I think that's what is very important. But having said that, as an organization, as you pioneering that technology strategy, part of your organization initiative, the key question is, what do I do? How do I bring this into reality? How do I adopt this in my organization? So you have an option. You have an option to look at point solutions, which is very vertically integrated. At the same time, you have an option to look at something which is built on open source, built on open standards, and gives you that explicit option of being interoperable. Being interoperable from a business perspective also gives you adoption to the ecosystem. And remember, there's always this beautiful circular ecosystem that you want to tap into. And that kind of sustains your product strategy also at the same time. So the choice, given the choice, tap into the open source, but make sure you have enterprise class support. What are those happy tools? Because you could pick, there's a lot of them out there, but you need to pick something which has that happy tool set, right? And then it's backed by enterprise support. When it's backed by that enterprise support, that gives you that ability to build your IP, your features, your use cases that you want to solve and not necessarily spend too much time on the everything under the hood. Now, we kind of understood what the complexities are, what business drivers are. Now, is edge, how do I kind of connect those dots when it comes to edge and make that a potential initiative within the organization, right? So if you look at it, if you can build or if you can future-proof your architecture from extending your hybrid strategy towards cloud. Why do I say that? You remember I spoke about consistency, right? All of that can be achieved when you're looking at a strategy where you could build your edge to work on any workload, on any footprint or any location. What that means to me is I'm pretty much putting together my architecture on a bare metal, on a virtualization layer, on the public cloud, or on the private cloud, or edge. So edge for me is just an extension of that hybrid strategy. When I'm a hybrid, I know I can move that same principles to an edge location also, to an edge footprint also. And that's exactly what we're going to discuss further. Because we've learned, thanks to containerization and cloud-native technologies, we've learned some of the best practices and now try to extend that, right? How do I really shift those cloud-native emphasis, the principles, the methodologies that we've learned towards edge? Now, one biggest issue that one of the market analyst team ran, did a survey and came back and let us know, is that 72% of business always cite manageability to be the biggest hindrance for deploying any kind of an edge initiative. Now, having said that, we've kind of understood what edge is. We've understood the business drivers, the technology drivers. Now, is edge a really differentiator? Yes. Why? Because I, as a business, can deploy any workload irrespective of where it is. That's a huge differentiator. Now, what also means to me is if I can scale up and scale down, that gives me the ability to drive metrics and policies driven, which is again translates into efficiency, right? Now at the same time, interoperability. I keep saying this, open source, and edge could be edge, right? It's not just a Kubernetes cluster on, let's say, AWS or on Azure. It could be anywhere. It could be on GCP, IBM, wherever, on-prem, your own hybrid cloud. So as long as you can bring a multi-cloud strategy where you could pretty much monitor the various health parameters of the devices and all the compute resources that you have, that's a boon for industries and organizations, right? Because you have one console, one single plane of truth where you could pretty much monitor all of those aspects. Now, another thing that I always want to emphasize is the fact that you should always keep this always-on innovation. You tap into that open source backed by enterprise class support. So if you could consider all these parameters, you see that edge computing can definitely be a differentiator for your organization. Good so far. So we've kind of hacked through into all of those components. How do I translate that? How do I connect the dots to actually make it happen, right? Let's take an example here. I've just taken one of the examples here, which is more like a factory edge. What could be the topology? And what should be the top considerations for organizations like you to embark on it? So in a typical factory, right from your L0 to L4, you have devices and the PLCs, the SCADAs, the plant data center, and then your headquarters-based data center, right? Now that could be on cloud, whatever, doesn't matter. Now, you could start with something which is a very small footprint, which is around the device, and manage the application lifecycle across it. How do I package my application along with the base image? Could be containers for sure. And how do I deploy it? How do I package it and deploy it? How do I ensure the whole cycle of CI/CD plugs into it? That becomes one of the important criteria for you to be flexible in terms of what your deployment strategy is. Now, within Kubernetes, for those who probably don't know, we have what we call a control plane, which is basically your master nodes and then your worker nodes. So you could define based on the number of devices to probably go one level high and bring in what we call a worker node. So these remote worker nodes can then be controlled by a control plane, which could be in your plant data center or in your headquarter-based data center. Now, what you can also do is go with a single node architecture. A single node architecture gives you the masters and the workers, and you can start adding workers as much as you want as you grow. Now, these are different topologies that you might want to kind of connect it back to your design and the fact that you will achieve what we call a purpose-fit architecture. Now, having said that, what is very important also is to be able to manage. Remember that 72%, it's a huge number, by the way. So if you have that ability to deploy and manage at scale, which means that you can achieve the configuration settings or pushing your software code with a new feature that's just added and being released to all of those devices with just the push of a button. Now, going back to the principles, the consistency again. So as long as you have that taken care of and you have a consistent, seamless experience for your devs, your security team, your operations team, you pretty much have it considered from a cloud native versus an edge perspective. Now, the last thing that I want to bring to your notice is, like I said, I will also touch upon the technology, some of the technologies that you can quickly adopt as a part of your initiative and try it out. What I've also done is put together the open source ones, and I've also put the alternates. If some of you guys prefer to have a piece of component which is also backed by enterprise class support, you could go for that. So one of them, I'll start with the ease of deployment. How do I go about it? So from a CD perspective, we have something called Argo CD. Now that's very declarative, pretty much ops friendly, and you could, there's links out here that you could go to GitHub, clone it and use it. I've also given you instructions in terms of creating a namespace and then using the install YAML file to deploy it. Now you could also customize. If you go to your YAML file, you could customize it based on your environment and deploy it. Now, if you want to go more, I know someone had a developer-related question in the previous session. So if you're looking at a developer perspective to see if I could build, test, and then deploy, the Tekton is a better choice there. So if you want, you could start with Tekton also. Now, all of this has an enterprise edition also, so you could pick it up and run it. Both of them are available as operators. I don't know if you guys understand. Operators basically extends the foundation of Kubernetes. So everything in Kubernetes is defined as a CRD, a custom resource definition. So operators, which is built using operator SDK, kind of packages that entire ops knowledge into an operator, which means it's just click of a button, you deploy it, and then you can roll back, do an over-the-air upgrade, and make that entire version control and all of that pretty much easy. Like I said, I have also the link, which is an alternate for the open source, which is supported, that you could pretty much try it with our OpenShift emphasis. Okay. We looked about ease of deployment. How do I scale? What does that help us scale, right? Now, we have something called horizontal pod autoscaler, which is very fundamental to Kubernetes. What it does basically is there's an API resource and then a controller. We call it a HPA controller. And this resource actually determines how your controller behaves. So based on the demand, you could increase the pods. Now, how do you increase the pods? You attach certain metrics to it. What are those metrics? As simple as CPU utilization. Naveen mentioned about CPU utilization, the memory footprint, and so on and so forth. So if you say my CPU utilization is greater than X factor, I could spin up more pods. Or my memory utilization is greater than X percentage, I could increase the scaling capability. Now, you could also define your own custom metrics. For some of the intelligent folks out there, they define number of users. So basically, more number of requests, more number of users. And we know for sure more number of users leads to more CPU utilization and more memory utilization. Therefore, you could, in a proactive way, take care of the scaling aspects, right? Now, scaling is not just scale up, it's also scale down. That's the beauty, because at non-peak hours, you could pretty much scale down as well. So that kind of eases out your scalability. Now that we've taken care of deployment and scalability, how do I bring that manageability into my strategy, right? So we've got a couple of upstream open source projects, one being the Open Cluster Management, the other one being a combination of StackRox and KubeLint. KubeLinter is basically, vulnerability scans. How do I look at my image distribution if I'm a global organization and I have various, data replication aspects and distributed repositories across the globe, different cities and so on and so forth. And Open Cluster basically is an advanced cluster manager for Kubernetes. Again, like I said, it gives you this single pane of glass, the dashboard for you to monitor the policies, the health indexes of various of your workloads, including the infrastructure. Now again, operators available. You could fork it, deploy it, test it out. You have enterprise alternates that you could consider as a part of your edge computing initiative. Now that takes care of the manageability. Okay, one last thing before we wrap this up. Scupper Now, single cluster communication for different ports is a paradise. There's no challenges there, not too much that I'm aware of, at least. Now, if you look at multi-clusters, and you want something at the application layer to kind of talk to different services internally within the service interconnect, there's this, about 6 years, quite mature open source upstream project that you probably want to consider. Now, the beauty of this is it doesn't require you to set up VPNs or firewall rules, because this is a layer 7 implementation. The typical layer 3 implementation is on the network side, but a layer 7 implementation is on the application side. So what it does basically is creates a service component that flattens the network. And you create a token, and you attach that token to an endpoint so that these services can talk to each other. Someone mentioned about this sidecar. This is typical to a sidecar kind of an implementation, but at layer 7. So what it does is flattens out the application. So it's a typical virtual application network, not required to go through the firewalls and so on and so forth. So that's quite interesting for developers. You could play with it. This is the innovation example that I wanted to show up, which is basically on a multi-cluster service interconnect perspective. Now, the last thing is how do I go about Scupper? I've taken a very simple example here. What I did is, because I can't have clusters all over, it costs me. So what I did is I took a couple of availability regions on AWS. One was the west and the other one was the east. I initiated Scupper on top of it, and then I created a token, linked it to the other service endpoints so that they're aware of which endpoints to discuss, and then I deployed a simple hello world front end. And I could see pretty much applications talking to each other through this beautiful virtual application network. Now that's very innovative, and I'm sure you guys would try that out and let me know. So I go back, consistency, interoperability, and scale. As long as you can extend your footprint, have the same consistent tooling set from your data center, irrespective whether it's bare metal, virtualization layer, public cloud, hybrid cloud. If you can extend that same principles, which are cloud native, to your edge computing, you see that being more a very good reality, I should say. So that's it from me. Any questions?
Thank you, Mr. Rajagopal, for such a passionately demonstrated presentation that you've given us. Very informative, and in fact, I found a synonymous phrase for me. Usually I would say, you're talking Greek and Latin. I think I'm going to say you're talking cloud native CI/CD to me. Yeah. So that was on a lighter note. Thank you. I think I'd like you to be on the stage, and I'd like to welcome Mr. Mayank Chaudhary, from Impact QA, the VP Sales and Marketing. Thank you.
Thank you. I appreciate it. Thank you.
Thank you once again, both of you.